The Arctic is one of the most isolated and hostile regions on Earth. Thousands of miles of frozen ocean stretch as far as the eye can see. Scientists have braved these conditions to investigate how this region is changing. Beneath them, the ice itself is constantly on the move, a real danger to anyone working here.
Just in the short time we've been away from the ship on the ice, the crack has not exactly opened up, but has deepened.
Researchers say the ice is becoming thinner and more mobile as the region is transformed.
The Arctic is changing, and we have consistently underestimated the pace of change.
And this change could touch millions of lives. It could alter the patterns of the world's weather. As scientists say, the Arctic enters what they're calling a new era. I'm in the high Arctic on the Svalbard Islands, about to set off for one of the remotest locations on the planet, a ship just 500 miles from the North Pole.
So we're all loaded up for a 3-hour flight by helicopter. I've just checked the temperature of where we're going, minus 19.5. Here goes.
The Arctic is the roof of the world. Mountains, fjords and glaciers forming a fringe that lies around a vast ocean. To most of us, it might seem too remote to be relevant. But this realm of ice and snow acts as a cooling system for the entire planet. So what happens up here could affect us all.
This is one of the most dramatic journeys I've ever made. A while ago, we saw an area where the frozen sea had broken up into what looked like pieces of a shattered mirror just lying broken on the surface.
Where we're going is so far off that our helicopter has to refuel, and the only place we can do that is on a Norwegian patrol ship, a vital staging post on our journey north. Norway is one of half a dozen countries with big interest in the Arctic, so being able to operate here to cope with the huge distances is essential. With the tanks full, we're off for another hour and a half of flying.
The further north we go, the more of the sea looks frozen. There are patches of open water, but increasingly we're seeing these large floes of ice joining together and forming what looks increasingly like a continuous surface that'll stretch up towards the pole.
The view is desolate, a landscape that seems utterly barren. But suddenly we spot a polar bear. Even up here, there's life. And then, amid an endless vista ahead of us, a tiny speck that's a very welcome sight, a lonely outpost of humanity. This is the Lancer, run by the Norwegian Polar Institute, a research vessel that acts as a mothership for science.
First impression, having just gone off the helicopter, is a great cloud of breath I produce every time I exhale. It's like stepping into a deep freeze. Minus 19. Home for the next few days.
We've arrived in a bustling community of 25 scientists from 10 different countries, working on and around the ship.
The whole point of this expedition, in fact the reason the ship is here, is to try to understand exactly how the Arctic is changing. And there's really only one way to do that, to get that better understanding which is to gather first-hand knowledge, and that means getting onto the frozen ocean, like this.
It's like a miniature university, with scientists from different disciplines, physics, biology, oceanography, all exploring different aspects of the Arctic. What's called ground truth, hard fact, really counts. So every day the researchers fan out across the ice, walking over a surface that's often only a metre or so thick. And they use a range of instruments to measure how the ice, the ocean and the air are connected, and to see how change in one affects the others. Even in the space age, when we have satellites, research often comes down to a shovel, and I'm put to work, watched over by a guard with a gun in case a polar bear gets too close.
That's coming off, I'm too hot already. So how big a hole do you need, actually?
A bit bigger.
A bit bigger. Make a little igloo. Hey, I've reached ice.
Polona Itkin is a specialist in what's called ice dynamics, how the ice moves. It's cutting-edge science, but still involves her digging dozens of holes, at least 30 in all, to drop a tracking device into the ocean below.
This is a buoy that measures the position and the ice thickness and snow depth of the location where it's deployed.
She'll bury the device in the snow. It'll keep broadcasting its position and details about the state of the ice. Its battery could last about a year.
We would like to understand how the sea ice cover in this part of the Arctic is behaving in the new climate. We know something about this ice that has been studied over decades, but we think that now the ice is different, and we would like to see how different and what does it mean.
For many of the scientists, a lot hinges on the thickness of the ice. It's a key indicator for how the nature of this world is changing.
Distance to water 142, distance to snow 186.
For Jennifer King, the challenge is to check whether her measurements of the ice match other observations. No one here is making any assumptions about global warming, so she wants to verify that what she's finding is in line with data gathered on a bigger scale.
So the next step up from this is a similar instrument which we hang below a helicopter, and that allows us to scale things up and say something about what the ice thickness is over a wider area.
But to observe what's happening over the entire region, you need to get even higher and use satellites in space, and then calibrate what they're seeing with measurements made down on the surface.
Once we know that the measurements from the satellite are accurate, we can then cover the whole Arctic and get an accurate picture of ice thickness.
And what they're finding is a shift in recent years in what's covering the Arctic Ocean. From ice that's tough enough to last several years to ice that's younger and thinner. For the head of the Norwegian Polar Institute, this is one of several major changes.
Over the last 35 years, we lost about 40% of the area in summer and also about 40% of the thickness, which means that we lost around 3/4 of the volume.
The sound of blocks of ice being squeezed together. When we speed up the video, you can see how rapidly the ice can shift around the ship, even in a few hours. This is nothing new, but the signs are that these cracks are becoming more common and they're opening up all around us. For anyone working here, it's a constant threat. Everyone has to wear a flotation suit just in case. And several times in the past few months, the scientists have had to hurry back to the ship. There's always someone keeping watch, and I see for myself how easy it is to be trapped on the wrong side of a widening gap.
This is our first day, and we've only been out a couple of hours, and to be honest, it got very, very cold. And what's happened, just in the short time we've been away from the ship on the ice, the crack has not exactly opened up, but has deepened. And the guys on the ship are concerned about us crossing it, which we'd just done a couple of hours back. So they're now going to send the ski mobile, pick us up, give us a safe journey back to the ship. It just shows you how difficult it is doing this kind of research out here. You're going to ride us over? Yeah? Okay. Thanks. Great, thank you. Rob, let's get indoors.
We make it back safely. Work on the ice has to stop, and equipment is hauled off in case it slips into the ocean below. The ship is a haven in a hostile world. The scientists and crew can warm up and enjoy 3 big meals a day. Here, for a while, you can escape the bitter wind. And it's easy to forget we're a tiny community drifting in a frozen ocean.
My friends back home, they wonder what are actually a navigator doing up here in the ice.
They might well wonder. The main engines are off, but the ship is still moving. The tail end of the Gulf Stream reaches up here. The ice is kept on the move by water and wind.
The drift of the ice is actually almost 100% activated by the wind, not the current. The current is very, very weak here, and it's the wind who's actually demand where the direction of the ice area is drifting.
But it's an amazing idea that actually we're moving now. I mean, you're not driving this
No.
ship, but we're being carried along with the ice.
Yeah, we are. And in January we had a big storm. 4 days first north, and that's make the pressure north.
It pushed you north.
And then it's just for 1 hour it turned with storm south.
And pushed you again south.
South, and then all the release of the pressure went with the drift, and we was up to 1.2 knots.
You were travelling at that speed without using the engine.
The whole area was just drifting, and we was following with it.
It's hard to grasp how massive areas of ice can move by as much as a mile in the space of an hour. You can't see it for yourself, but the ship's instruments plot how much the ice is shifting. And this is a record of how the ship has moved since the expedition began back in January. What makes this mission so exceptional is that it was launched in the total darkness of the polar winter. That's when, this far north, the sun never rises for months on end. Under floodlight, the eerie sight of the Lancer being inched forward with the help of an icebreaker. Conditions were punishing, the cold and wind combining to make this some of the most extreme fieldwork ever conducted, and sometimes going wrong. Watch what happens to this weather balloon. For those involved, never seeing daylight and enduring bitter cold took their toll.
I think it was one of those things where you don't realise how much it affects you till afterwards. And I think back to January and realised how tired I was all the time. But at the time I didn't really realise it was the light, I just thought I was exhausted.
Fatigue in the deep, dark cold was one threat. Another was what lay beyond the floodlights, a constant danger.
This was in February, early February, and we were out with these instruments. Two of us were doing what scientists do, and we had our heads down a hole, and we had one guy watching for bears. And suddenly he says, "Oh, there's a bear."
Polar bears may look adorable. This one approached while we were on board, but they are the top predator in the Arctic. They're extremely powerful and can see people as food. So everyone who goes out onto the ice needs a guard with a gun as a last resort.
The bear was at about 25 meters from us. So he was really looking at us, really interested what were we doing really kind of majestic, king of the Arctic kind of pose. It was absolutely beautiful. Of course, in the time you're not thinking it's beautiful, your heart stops, you're thinking that bear's really close and it's really big.
And all the time, the ship itself faces danger, with blocks of ice pressing against it. Over the past 100 years, many vessels have been crushed this way, but the Lancer has survived, and that's because of a very special design, a legacy of a giant of polar exploration, Fridtjof Nansen. He built a ship called the Fram, with a hull that was rounded, so as the ice squeezed it, the ship was lifted, as the Lancer is doing now.
Nansen made a ship as a nutshell, and the whole idea was when the ice kind of comes and pushes into the ship, it is lifted up and not crushed. And this is also what happens here. A few weeks ago we had this 3,000 tons vessel lifted up 1 meter by the ice, so it's enormous forces in action.
And it keeps the ship safe because it doesn't get destroyed, it gets lifted instead.
Exactly, it's just lifted up instead of being crushed.
Nansen went further north than anyone before him, and because of his achievement, he's revered in his native Norway, personifying the kind of rugged pioneer that many Norwegians aspire to be.
Because he's one of our biggest Norwegian heroes. We are made for the coldness and the hard life, so we can handle it.
And you feel at home up here?
Yeah, well, I live in Florida also, so
That's a confession.
you know, it's the contrast, so I like that. So yeah.
Because this expedition is all about science, researching the state of the Arctic, there are little laboratories crammed into all kinds of corners on board. This one is run by the people looking at the chemistry of the oceans. And if I step through here, I can show you the lab that's run by the biologists. They're the people measuring and evaluating all the different forms of life that they can find, including plankton down beneath the ice.
Doing research under the ice takes real guts. Looking back up, the brightest light is the small hole cut in the ice for the divers to get through.
It makes a strange feeling if we go down, very slowly to 30 meters, and you know that you can see the little square hole above you, and then you know that you're 3,000 meters below you.
The ocean is extremely deep. Near the surface, the water is cold, about minus 1.9 Celsius, but further down, the water is warmer, brought here on a current all the way from the tropics. And it's dark, because most of the light is blocked by the ice and snow above.
In spite of it being very dark there, there's still some life. There are some plankton in the water masses, some animals swimming around, some jellies that we can see. And also we are specifically looking for the animals that crawl underneath the ice. And they are part of the ice-associated fauna.
These creatures, so small you need a microscope to see them, are incredibly important because they form the foundation of the food chain that leads from plankton up to polar bear. For biologists, a big question is what the thinner ice means for Arctic life. Some species may well do better, but others that depend on the ice may be facing a harder time. How will they cope if the ice retreats? That's one of several key questions about the Arctic that many people want answers to, including the future King of Norway and his wife, the Crown Princess. They flew out here to support the expedition.
Even though we're here at the Arctic ice cap, we know that what's been done here and what happens here and the research that's done here is a global, in a global context. And that means that we need to improve the models so that we know more about the consequences of what's happening.
The idea is that change on a massive scale here at the roof of the world must have a knock-on effect on the global flow of weather.
The Arctic is changing, and we have consistently underestimated the pace of change over the recent years, and there are reasons to think that this will continue. And the most important thing with the changing Arctic is that it also affects weather and climate elsewhere. So not only affecting this region, that's important in itself, but it also affects the monsoon, it affects agriculture in the United States, and so on and so on.
The expedition will run until June, but for us, after 4 days on board, it's time to leave. I've learnt how tough it can be investigating changes up here that could eventually have an impact on us all.
Step outside and talk of global warming seems ridiculous because it's always going to be freezing here in the winters. But clearly something is stirring in the ice, the water, the animals.
Change will not happen overnight, but we're on course at some point this century for this frozen landscape to be completely clear of ice in the summertime. No one can be sure when that might happen, but if the scientists are right, we're already witnessing one of the most striking transformations anywhere on the planet.